So every year in the United States of America, 5 million people in intensive care units get central lines put in them. After 10 days, 4% of these patients develop an infection. That's 80,000 infections a year. This is fatal 5 to 28% of the time. This is Dr. Peter Pronovost. He is a critical care specialist at Johns Hopkins Hospital. And he said, we can do better than this. We should not be having so many complications and so many deaths. And the way he solved this problem was with the use of a checklist. The checklist reduced the infection rate 66%. In 18 months, it saved $175 million and 1,500 lives just with one checklist. They thought this was a great idea. What else can we use this checklist for? The World Health Organization put together a safe surgery checklist. This checklist reduced the rate of complications 35%, reduced deaths 47%. This is Atul Gawande. He's a writer. He's a surgeon. He has studied patient safety, and he wrote a great book called The Checklist Manifesto discussing how checklists can be effective in all kinds of situations, from running restaurants to assembling buildings. We have big, complex systems in society, whether they're software systems or other kinds of systems. And there are two classes of mistakes we make when working with these systems. They're mistakes of ignorance. These are when we make a mistake because we don't know something. And there are mistakes of ineptitude. That's when we don't use something we already know. Most of the errors that happen today fall into this category. Failure is really about systems being complex and humans failing to understand them. In 2013, the United States government tried to build a new healthcare system, healthcare.gov. This didn't go very well. As a result of this, they rethought how they were going to build digital services. Instead of outsourcing everything, they started to build their own teams. They built 18F, which develops, and the US Digital Service, which consults with other agencies. The US Digital Service found that government services were late. They didn't work well. They found they were over budget. And they said, how can we increase the success rate of our digital services? Well, with a checklist. They call this the US Digital Services Playbook. And their playbook contains 13 plays. They start at the beginning of the project, saying, we need to understand what the people need. We want to consider the whole experience. And this goes on and on. This is the first checklist, understanding what people need. And it's comprehensive. It requires you to talk to people in the service. It makes sure you understand the needs and the goals. It walks you through testing. And it makes sure at the end that you follow up with people and see that it's really meeting the needs you set out for the project to make. So checklists are a really important habit of effective software development teams. What kind of checklist can you use? Well, when you're starting out with a new employee, an onboarding checklist helps make sure that they have everything they need to be productive on the first day. An offboarding checklist ensures that when people are leaving, they don't have access to services and systems they shouldn't. We have a checklist for administrator access, which tells us who has control over each service. When you're doing projects, project-specific checklists like how to put together a new newsletter, how to start a podcast, how to migrate your server. Those kinds of checklists are super helpful in making sure things go right. Checklists can be used throughout the development process for localization, for accessibility, for testing. Checklists during deployment ensure that data is migrated at the right time and completely, and ensures that alerting is turned on when needed. Now, not all checklists are created equal, and just putting together a checklist alone won't make sure that it works. And so this is a checklist for creating effective checklists. A copy of this is in the handout. Checklists are the first of the 8 habits of effective development teams we're going to talk about today. We'll cover onboarding. We'll talk through communication, standards for coding, code reviews, the use of version control, automation, and at the end, reflection. So who here has started a new job and They got there on the first day, and everything was working great, and you were deploying code hours later. Did that happen to anyone? That didn't happen. So wouldn't it be great if on your first day your computer was there, and your phone worked, and all of your usernames and passwords were set up? Wouldn't it be great if we had a checklist for that? And that is step one of making sure you have a good onboarding experience, is knowing what's included. Now, when it comes to development teams specifically, there's a lot going on your computer, a lot of tools, a lot of dependencies that you need to get set up. And every company and every system is a little different. Instead of making people learn this, using a virtual machine, using Vagrant, using tools like that, ensures that these environments are set up quickly, that they're set up consistently, and that they're set up completely. In addition to using virtual machines, using scripts to automate the configuration of individual preferences and accounts on the main machine is really helpful. A second way that teams ensure effective onboarding is to set their employees up with a buddy. Having an experienced employee guide you through the process gives you the confidence to ask the silly questions. It lets you ensure that you don't miss anything. And this can be a process question. It can be a finance question. It can be, where's the bathroom? Or where do I get good coffee? But having someone ask these questions of makes the onboarding that much smoother. And you want to schedule regular check-ins. This is not just something you do on the first day, but it's something you do for the first few weeks and the first month to follow up. The other thing is that every time you onboard someone, this is an opportunity to improve your onboarding documentation. You can look through them and say, what did we miss? What's changed and is now out of date? Which are sections that are confusing or incomplete? Now that folks are on board, they start writing code. The thing about code is everyone has their own way of doing it, from things they learned from school or from previous employers or from stuff they've copied and pasted from Stack Overflow. Now, if this happens, it means your project looks like a mess. Having standardized rules for coding ensure that code is formatted consistently and it looks like code for your project and not Paul's code or Jane's code or whoever's code. It also reduces the number of bogus differences that show up in patches and pull requests. And finally, when you use automated tools like linters to enforce standards, it helps catch all kinds of other errors that you might have missed. WordPress folks are writing a lot of PHP. And the good news is there are terrific tools for standardizing and linting your PHP. The first one is the PHP Code Sniffer. Who here is using the PHP Code Sniffer? Excellent. And so as you might know, there are 4 different rule sets you can use out of the box. The core rule set, some extra rules, rules for inline documentation, and finally, rules for WordPress VIP. Running through a piece of WordPress core, we can see that it will catch a number of errors right away. In fact, the WP login file has 759 errors, 151 warnings. Now, if you had to fix that, that might take you a long time. But the good news is that PHP CBF, the companion tool to the Code Sniffer, can automatically fix many of these classes of errors for you, so you don't have to do that. It saves time, and it prevents you from making typographical or other errors which would break things. When you're setting up a new project, you can use Composer to install PHP Code Sniffer automatically and keep it up to date. This is all that you need to make that happen. Now, PHP CS has a ton of rules, some of which might apply to you and some of which might not. You also might have folders you want to exclude, like vendor code. Setting that up, passing those sorts of flags every time is cumbersome and can be error-prone. The good news is PHP CS lets you specify all of these settings in a file in your project's directory. That means you don't have to worry about it. You type PHP CS, it does everything for you. In addition to standardizing PHP CS, or standardizing PHP, you also want to standardize your JavaScript. Now, the good news about JavaScript standards is there are so many to choose from. Everybody has come up with one. Now, which one you pick is really up to you, but everybody on your project should agree with it. for folks here working on WordPress projects, you're probably going to want to use the WordPress standard. And the tool to enforce that these days is ESLint. This is a sample ESLint configuration file. It uses the WordPress rule set, and it adjusts a couple of settings to make it work correctly. Another problem you might run into with different team members is they are going to use different editors. And they might have different settings. Like, I'm going to use tabs, and he's going to use spaces. Or someone's going to have a trailing new line, and someone else might forget. But the good news is you don't have to worry about that either. There's a standard called editor config. And by putting a .editor config file in your project's directory, you can enforce these rules automatically. It's supported out of the box by many editors, and there are plugins for dozens of others. The third habit of effective development teams is communication. It is really important for your team members to feel safe as part of your team. They have to be you, as the team leader, have to be willing to be wrong, and you have to make it safe for others to admit when they're wrong. This is Amy Edmondson. She's a professor of leadership and management at the Harvard Business School. She came up with the concept of psychological safety, which is the belief that one will not be punished or humiliated for speaking up with ideas, questions, or concerns. Now, a lot of people, when they hear this, start to worry. They say, well, it's great that I make you feel safe, but how do I also hold you accountable for your work? What happens when something goes wrong? Well, the good news is that psychological safety and accountability are not at odds. In fact, they work best together. If you're in an organization or a team that has low safety and low accountability, you end up in the apathy zone. No, nobody really wants to say anything, and nobody is accountable for that poor work. Now, if one of the things is high and the other is low, people can get either too comfortable or too anxious. But if you're high and to the right, that's a team with a lot of psychological safety and a team where everyone is accountable. This is where you have the opportunity for learning. Another important part of communication is having regular one-on-ones. It means you are speaking with your manager, and if you're a manager, you're making time to talk with all of your direct reports. It's important you don't skip them. You might be busy. This should be one of the top things on your plan for every week. And the other thing is don't just show up for the one-on-one for chit-chat. You should have an agenda. The Management Center, which teaches people how to run nonprofits, has a terrific sample agenda for check-ins. I've included a copy of that in the handout. A lot of folks here are on remote teams. It's important to make sure that they feel included. You want to communicate with your team through a combination of face-to-face interaction and video chat. When it works for your team, you can leave a video call or a phone open. Folks are also very likely to be using Slack or other social tools. And they're great, but not all Slacks are created equal. It's important that you're thoughtful and deliberate about how your team sets up these tools. The folks in Slack have a great guide for how to name channels, how to set up users, and making sure your time spent there is effective. A copy of that also in the handouts. Now, software teams spend a lot of time with bug tracking systems. If you don't write a bug for something, the chances are it won't happen. Bugs are sort of the currency of software development. And they're how you communicate with other engineers. But a lot of bugs are not well written. They're confusing, they're unclear, they're incomplete. The following are some guidelines to help you write bugs effectively, so when you communicate with your team members, they know what you want and can complete the task. The first is to make sure that you write the bug. People are often hesitant. They might say, well, this problem isn't really that important. Conversely, they might say, everybody has seen this problem already. I don't need to write it up. It's much better to have 2 or 3 or 5 copies of a problem which you've marked as duplicates than not to know about it at all. Second thing to remember is that each bug report or ticket should contain only one bug. If you find a whole bunch of problems, even if they're related, and even if they might have the same root cause, you should write them up separately. Similarly, don't repurpose a bug report. if someone completes a task and at the end of it, it uncovers a new problem, that new problem gets its own bug report. A bug report has 3 key parts to it. First is what you did. That's something you saw, something you typed, something you clicked, something you heard, what happened, and what you expected to happen. It's the difference between what happened and what you expected to happen that makes it a bug. Now, when you look at lists of bug reports in Jira or Bugzilla, you see long lists with dozens or hundreds of items. Often, the only information you have to go off is the title. So a good title, just like a good headline in a newspaper, is the key to an effective bug report. A title should concisely summarize the problem. If this title is about a specific error message, you can include keywords from the error message or error numbers in the bug's title. Because you have a limited amount of space for your title, you want to avoid things like filler words, articles. Avoid conversational writing. It would be nice if it did this. I would like it to do that. You can put that in the description, but keep it out of the title. And avoid titles with words problem, bug, or issue. That should be self-evident. When it comes to descriptions, there are a few important things to include. First, if the bug relates to a particular error, include the full text of that error. Include any error numbers. If there's a crash, include parts of the backtrace. Next, it's important to know, is this a problem that happened only once? Is this a problem that happens intermittently from time to time? Or is this a problem that happens every time? How reproducible is this bug? And what are the steps to reproduce this problem? Think about the steps at the right level of detail. You probably don't need to include take the computer out of the box, turn it on, and log in. But if this is on the Mac Setup Assistant, those would be important things to note. For web bugs, is this something that you need to log in for, or is it something you need to be logged out for? Is this occur on a Retina display, or in both, or non-Retina display, or both? Think about all of these things someone would need to know to reproduce the problem you just saw. And most importantly, describe the actual results and how they differed from the expected results. If you were to write in a bug, I saw some green text, someone might look at the bug and say, oh, green text, that's terrific, no problem, this isn't a bug after all. But if you say, I saw green text and I expected red text, or I saw green text and I expected green shapes, then they would know why you thought it was a problem in the first place. Another important thing to remember are bug reports aren't Twitter, and this is not a time to use slang or colloquial language. Avoid saying things are busted or acting up, because that is not an actionable report. You also want to avoid relative pronouns like it or that. It's hard to know 3 hours and 3,000 miles removed if it refers to the window or the user or the icon. Another important thing to think about when writing bugs is to describe what happened, not what didn't. It's very common for people to say, well, nothing happened, or this didn't work, or this does nothing. But none of those things are probably true. It's much better to say, oh, well, the screen went white, or the computer crashed, instead of it didn't let me do this. The other thing about bugs, in addition to writing them, is prioritizing them. It's important that your team have a shared understanding of each level of priority. I'm going to walk you through an example of how I think about bug priority. You don't have to think about it in the same way, but everyone on your team should share your understanding. First is a P1 bug. To me, a P1 bug should be reserved for things that are really, really important. This is so important that you can interrupt someone to fix this problem. It means if they're in a meeting, you can pull them out of the meeting. It means if they're at home, you can call them. What kinds of bugs are P1 bugs? Well, my site went down. That's a pretty bad bug. If the entire page layout is broken and unreadable, did a JavaScript change stop all of the other scripts on the site from running? That's bad. Were we hacked? That would be a P1 bug. Second, P2 bugs. P2 bugs are most important bugs. These are bugs you're going to want to work on right away during your day. And finally, P3 bugs are sort of everything else. These are bugs that are nice to have. We would like to fix them. We're probably not going to fix all of them. We fix them after we fix the P1 and P2 bugs. But the other important thing to note is that it's okay to fix these sorts of bugs opportunistically. If you're changing a file and you're fixing a P2 bug and you see an easy P3 fix, go ahead and get that done. Next important habit of effective development teams is to use version control. Now, there are tons of version control systems out there. You could be using Bazaar, or Perforce, or Fossil, or Mercurial, or CVS, or Subversion. You're probably using Git. This is great. As long as you're using any version control system, that's better than not using a version control system. The tips I'm going to show you today pertain to Git. Git Extras is a really terrific package. It contains 55 different tools that extend Git to do things you might otherwise have to do manually. Here are a few examples. Git Summary will show you the activity on a package. It tells you how long something has been around, how many commits are in it, and who's been a significant contributor. Git Delete Merge branches will automatically remove branches that have been merged into your current branch, such as master. Git Setup is a shortcut for creating new projects, where it automatically initializes a repository, adds all the files, and makes an initial commit in one command. Now, who here has accidentally checked in a file into Git with, say, a password or an Amazon secret key that they needed to pull out? All right. Now, the good news is you can get rid of this. Git Extra has a handy shortcut tool called Git Obliterate. It uses the Git filter branch tool, which has a long and complicated syntax. This is much easier to learn. The downside is that this is really slow. For a large repository, this can take hours or tens of hours to rewrite the entire history to remove your secret file. The good news is there's a tool for that too. This is called BFG. BFG is Git filter branch, but backwards. This tool is written in Java. It's 10 to 720 times faster than Git filter branch. It can do two sorts of things. One is that it can remove the individual files that shouldn't be there. The other thing it can do is it can remove classes of files. For example, GitHub won't let you push really large files. So if you're migrating a repository, say, from your internal tools or Subversion to GitHub, you'd hit an error. BFG will let you remove these large files. Another handy tip is to look for a great Git GUI client. Now, I use the command line all the time, and I'm super productive with it. But GUI tools let you easily see the status of many activities at once, and they help you manage commits. Speaking of commits, it's important to think about commits in a modern way. Commits used to be expensive, but commits in Git are cheap. So you want to commit early, and you want to commit often. It's much better to make a lot of small commits than a few really big commits. And when you think about what goes in a commit, think about it as a concept, an idea, a feature, and not a time unit like a day or week, or a logical unit like a file. This is an example of using Tower to commit a couple of lines from one file while ignoring other parts of the change. This means it's easy to collect changes in several files that are related conceptually and put them in the same commit without having to pass a ton of flags to Git. When you're using version control, you're going to create a bunch of branches. Your team wants to have a standard method for naming and using branches. One such example is to create feature branches with the word feature and the name of your feature. And we use fix to indicate bug fixes and style to indicate CSS-only changes. Another method might be to include the name of the Jira ticket, for example, in the branch name. Whatever you use, make sure that it's consistent within your team and everybody can see the name of a branch and understand what it means. When you're using the command line, having tab completion makes it easy to get through long branch names without typing a bunch of keys. And the good news is both Git and the Git Extras package have tab completion methods. Finally, Git offers a handy way for tracking down when something broke. How often has it happened where you've had a problem on your website and you know it sort of used to work, but you're not sure when, and you're not sure what changed, right? That's happened. And how many times have you sort of walked through commits one at a time, trying to figure out, that takes a long time. It can take hours or days. The good news is git bisect can speed that up a lot. Git bisect runs a binary search automatically through all the commits between the bad commit and the good commit. So you start it off, you give it an example of where something is broken, such as today at master. You give it an example of a commit where something worked when things worked well, and it goes off like this. It will tell you there are, in this example, 29 revisions left to test, which will take 5 tries. You run the test, and you see, did this work or not? If it worked, you say git bisect good, and it moves along. It says there are now 4 steps. If the next step doesn't work, you say git bisect bad, and this continues until you get to the end. And finally, it will say this is the first bad commit. Now you know where it broke, and you can take steps to fix it. When you're done, you type git bisect reset, create a branch, and start on your fix. Code reviews are an important part of any effective development team. Here are some notes on how to make code reviews work for you. First, just remember that you are reviewing code and not people. And conversely, when someone is reviewing your code, don't take the review personally. It's not about you, it's about that particular change and that patch. Another thing to remember is that code reviews are not architecture reviews. These are not time to discuss the scope of the entire project. So why do you perform code reviews? Well, first, they help you catch bugs. You can catch some of your own bugs, but a second set of eyes will really help you catch even more. Second is to ensure readability of the code. It might be obvious to the person who wrote the code why something is written the way it is, but it might not be obvious to the next person who looks at it. Code review will help catch those sort of things and make sure things are properly documented. Second, code reviews help you have a healthy engineering culture where people are used to learning and improving their code through peer feedback. Here are a few rules for code review. One is that everyone's code gets reviewed. Code review isn't just for some people. It's not just for new people. Code review is for everyone. Second is that code review shouldn't spend time on things that can be reviewed by computers. So your test coverage tool can tell you how much test coverage there is. Your linting tool can catch small mistakes. Those are not the kinds of things you need to spend time in code review on. Another thing that's important is that when you do the review, you want to do the review before it's merged, not after. Code review is a collaborative, iterative process. It's not something where I throw code over the wall and you throw it back. It's a dialogue. You ask questions. We answer them. We work together to make sure the code does what we want it to do. What are some things you can look for when performing a code review? Here are 4 things. First is the intent. What is it this code is supposed to do? And should we be doing this in the first place? Second, think about the design. Are we doing this the right way? In the case of WordPress, is this idiomatic WordPress? And is this the right place? Are we working at the right level of abstraction? Once we're sure the design is right, we look at the implementation. Did we do what we said we were going to do? Did we say we're going to build a fridge and end up with a microwave? It would be a lovely microwave, but it's not a fridge. And then grammar. Are things named well? Are they commented well? Do the comments explain why something is done and not just what is being done? And lastly, it's important to have group code reviews where you get everyone together. This is a time to model best practices for code reviews. When you do a group review, use real code, not fake code. And you can start by reviewing the code of the most senior person in the room so nobody else feels picked on. Next important habit of effective development teams is automation. There are things computers are good at doing, and there are things people are good at doing. And if you're doing the same task, say, more than 3 times, this is a good candidate for automation. We talked about onboarding. a lot of your onboarding can and should be automated. Another great target for automation is your build system. You can use tools like Grunt and Gulp to make sure that your files are compiled and linted consistently every time. What kind of things can you use your build system for? You can use them to build CSS. You can convert Sass to CSS. You can minify CSS. You can use tools like PostCSS to add browser-specific rules. For PHP, you can lint the code and make sure the syntax is valid. And you can use PHP-CS to ensure your code is clean. You can use build systems to minify SVG files. You can use build systems to check JavaScript for errors and to minify it. We have a build script that checks permissions on all the files in the repository to make sure we don't accidentally check in a file with the execute bit set or a folder without the execute bit set. The build system can also check spacing to make sure that tabs and spaces aren't accidentally mixed in the wrong file. Continuous integration tools like Travis connect to version control tools like Git and GitHub to make sure that your tests and your linters can be run automatically. You can do something like continuous delivery to put things in a deploy-ready state, or even continuous deployment, where things actually deploy whenever tests pass, and then use rollback to push things back to a known working version automatically whenever things fail. And the 8th habit of effective development teams is taking time to think and reflect and learn. There are 3 methods I'm going to discuss today. The first is the idea of a blameless postmortem, which was popularized by the folks at Etsy. The second is the use of a failure report. And the third is an after-action review. Who here has heard of a postmortem? All right, who here is using them regularly? All right. Now, I thought about that when I was putting together this. And I thought I understood how postmortems are supposed to work. But it turns out I was wrong. There's a lot of details in there that can make the difference between a successful and an unsuccessful postmortem practice. Let's take a look at some of the information Etsy discusses in their debriefing guide. First, failure happens. This is inevitable. And it's important to understand how an accident happened to prevent it from happening again. You need to think of a postmortem as an opportunity to learn and not an opportunity to fix things. Typically what happens is there is this cycle of blame and name and shame. So someone takes an action, something fails, they get punished, team starts to trust each other less, everyone's trying to cover their butt, nobody tells management what's wrong, error rate goes up, and we're back to where we started. When you're conducting a postmortem, as the leader of the debriefing, you want to approach this with a beginner's mind, and you want to encourage everyone on the team to do the same thing. The blameless postmortem has 5 key things you're going to uncover. 1 is what actions the person took at what time. 2nd, what effects they observed, what expectations they had, what are all the assumptions they made, and then what was their understanding of the timeline of the events as they unfolded. They need to do all of these things without fear of punishment or retribution. This is really important. You might want to punish somebody, that's your first instinct, when they make a mistake. But if you think you're going to be reprimanded, you're disincentivized to give all the full details needed to really understand the mechanism, the pathology, and the operation of this failure. The other important thing I learned in reading about postmortems is that they are about the how and not about the why. You want to know how everything happened. The other thing is that you are looking for descriptions of how things happened, not explanations of why they happened. A lot of the knowledge that people have is tacit or implicit, this sort of invisible expertise. And by having these sorts of conversations in your postmortem, as a facilitator, you can draw that out. The second way of thinking and reflecting is the use of a failure report. I used to work with Engineers Without Borders Canada, and they're a nonprofit based in Toronto. They invest in social enterprises in sub-Saharan Africa. In the NGO sector, it's very common to hush up anything that went wrong. Because you're so reliant on donations, you're worried that if you say you made a mistake, that your funder will run away and fund somebody else. Turns out it's not true. So every year, at the end of the year, Engineers Without Borders, in addition to putting out their annual report, discussing all of their successes, they put out a failure report, talking about what went wrong and what they learned from it. And failures happen at every level, from a student at an internship all the way up to the CEO. They can be tactical, they can be strategic, they can be failures from the graphic design team. Now, when you're putting together a failure report, 3 common things that can go wrong. One is you think there's one process for everything. Not all projects, not all teams need the same size and type of process. A second problem is people conduct these sorts of analysis only at the very end of a project. You should be doing learning all the way through at individual checkpoints. If you use Agile, you can do learnings at the end of a sprint. And then the third problem is that people don't make use of what they actually learn, which leads to articles like this one in the EWB failure report. The third method for reflection and learning is the after-action review. This is something that the US military does all the time, but it's also used in business. This is Marilyn Denning from Fourth Quadrant Partners. And she says that the purpose of an after-action review is to test out and refine a group's thinking and actions in a timely way while there's still time to course correct and improve the outcome of a project. People think an after-action review is a meeting, they think it's a report, or it's a postmortem. It's none of these things. It's this living, pervasive process where you are explicitly linking lessons to future actions. An after-action review will answer these 5 questions. 1, what were our intended results? 2, what were our actual results? 3, what caused these results? What did we do that we can sustain or improve? And finally, and most importantly, when is our next opportunity to test what we have learned? You do not want to only do a postmortem at the end of a project. You want to do them early. You want to do them often. At any time there's an incident. It's really shitty to do this huge project and then a postmortem. It's way too late at that point. Postmortems also aren't one size fits all when you're reflecting and learning. Sometimes it's okay to sit back and make notes. When you have a large team, the key component of learning and reflection is to build trust on your team so people feel safe to contribute. When you're on a small team, you might already have that trust, and a process is less important. Any sort of reflection and learning should, 1, be about the type of learning that's most valuable to you and most valuable to that specific activity. You want to think, when can I next apply this learning? The action of stopping, taking time to reflect, to step back, that's what's really important. Even if it's as simple as taking 5 minutes on your ride home to ask, what did I learn today? Thank you.